anyhow, in the previous talk, you got an overview of the glideinWMS as a general. Here we go in a little more details about how the front end works, and I hope it will answer also some of the questions you have between the talks. So just a reminder, what we were just talking about, just for the record. And this I want to stress again. The factory is just the slave. The front end is what really drives the glideinWMS system. This is what decides where glide is gets sent to. And this just does the dirty work of actually submitting the glide together with the glide startup, which actually does the configuration of the worker. But the front end is really the head, the mastermind of everything before conduct kicks in. Again, about the end-to-end relationship, we talked about this in the previous talk. So let's go a little bit more in detail of how the front end works. So the front end system is composed of the conda daemons. So the conda daemons are actually part of the front end system. Without the conda daemons, nothing will work. You just install the front end that comes from glideinWMS. I can guarantee you will not run any jobs. Then you have the glideinWMS front end proper. You will need secondary clients, both for submitting jobs and for the front end to actually work. And you will need a web server because the code is delivered to the glidins through HTTP. So you need to run a web server somewhere, typically alongside the glidin front end. Doesn't need to. And the glideinWMS front end process itself, or glideinWMS entity itself, is composed of group processes who do the real work, and the master front end that controls all the others and aggregates the monitor. So essentially, you will have a tree of front end processes so that you can actually differentiate a little bit among different group sites if you want, or different users. You get a little bit of flexibility. You don't need to. You will always have at least a group, but you can have more than one. And the master front end is just like the condor master. Essentially starts the others and then does some monitoring. So here is the big picture. This is hand drawn. You can see it's not nice. So essentially, you have the master front-end process who will then spawn the various groups, and then the various groups are actually the ones that talk to the center manager, submit nodes in the various factories. The fact that there are one and one for each doesn't mean that you need to have a single group for each factory, but you can have different submit nodes and different factories talking to the groups talking to different submit nodes and different factories, but the center manager can only be one per front-end instance. You can have different if you really want, but that's just overkill. So the common processes, we explained this enough in the previous detail, so I will not repeat this out, but just as a picture, you have to have a collector negotiator and a bunch of submit nodes. And this is the condor part that you have to install alongside with the front end, and you have to administer it. You have no execute machines, although you can. There is nothing to prevent you to mix a gliding pool with a locally installed condor cluster. The front end should still do the right thing. I haven't tried it in a long time, but the matchmaking and the requests should still work the right way. Now, as I said, the real work is done in the group processes, and this is actually the binary. It's all Python. So you will see, if you do a PS minus EF, you will see this running. This is what is really doing the work on your node. And you will have one process per group. And in the rest of the talk, I will usually refer to the front-end group as front-end. So don't be confused when I say just front-end, and really refer to the front-end group. And they are just controlled by a master, which is gliding front-end py, and this is really what you end up starting, and this just forks all the other groups and controls it, similarly to what the control master does. But it also does aggregation of the monitoring, and we'll talk more in details more about this. you get nice web monitoring. It aggregates it so that you can see the global picture. You don't have to look at each group monitoring separately, although you can.
What defines a front-end group? Basically a set of submission points?
Whatever you like. You can have different match expressions, you can have different submission points, different factories. It's just up to the front-end admins, and I think most front-ends end up with one group. You will see an example of what CMS has been doing, where we have a bunch of them, and it can be quite handy. But you are not required to have more than one. So you have seen this. Essentially, the front-end is really the brain, the site-level negotiator. And here you have how it works. Essentially, find all the jobs, find all the images, match them, count them, and then request glidines, start again. It's a continuous loop. So nothing too fancy about it. And yeah, you can talk to more than one factory if you have more than one. And OG provides two right now, although I know that a lot of you use just one. And again, I want to stress it is a two-level matchmaking. Once here, and the two should be in sync, whatever sync means, or things will not work. Or they will work, but not the way you think they should. So, as we said, the matchmaking is implemented centrally by the view admin, not by the users. And you can use any attributes in the job and in the factory class ads, factory entry. And should be kept with the negotiator, which is not centralized, and this can be a problem. And one way is to define it in the gliding start expression, which we talked about. So if you define it in the start expression, something that is equivalent to the centrally implemented front-end configuration, it's still centralized because you will define the start expression centrally in the front-end configuration. And however, one is Python expression, the other is a class of expression. So we will need to do the translation yourself and do it right. Plus, Condor does some automatic requirements which can screw you up sometimes without you knowing. And then you also have to ask the users to not provide any requirements by their own, because else you can start glidings that will never run any job because the job requirements don't match. You don't need to, but this is actually quite an useful way to minimize the problems you will have. So here is an example what you can have as a matchmaking logic. So this is a classic one. Although I don't really recommend to use it exactly like this, but this is easy to represent. So essentially, this is the actual matchmaking expression that you set in the front-end config, and you say, set is Python. So essentially say, if a job has desired sites defined, make sure that the gliding site, which is defined by the gliding, the entry in factory class ad, actually is in this list. So this is just Python way of saying it. And then to make sure that you actually the gliding does the same, you rewrite the same thing in the class ad language, which essentially is string member gliding site in the desired sites split by comma, which is like the same, and this is equal to true, so it doesn't evaluate to undefined. So this is just a fancy way to say the first part. So it's flexible, it's powerful. It just can be a little bit confusing when you have to write it into different languages and make sure they are consistent. I will not speculate if glideinWMS will ever support directly the class ads. You can ask Bert when he comes here tomorrow or on Thursday. Or even better, Friday, when we have the session dedicated to the feedback. So let's get more into the actually inner working of the front end. and down to the communication protocol. I mentioned in the previous talk there are no listen sockets. All communication is one way from the front end to the factory. And even in the factory, there is no listening ports in the glideinWMS daemons proper. Everything is handled by the collector. So all the communication is based on class sets that go to the collector on the factory. And all the security is implemented in the collector. So anything that Condor can do, we can do. Anything the Condor cannot do, but it works fine. I don't have any complaints right now. So the standard command line tools are used for all the communication. Condor status, Condor advertise. This is actually used inside the front-end processes themselves, and you can do the same for the command line if you want, and it will work just the same. I'm not explaining exactly how to use them, but if you want to look in the code, it's fine. The protocol is essentially a pooling loop, as I mentioned before. So essentially, the front end will read the factory class sets from the factory collectors, will match against the jobs, and I skipped a little bit step there, which means get all the jobs from the local SCADs, but that's not protocol toward the factory. Once I have all these matches and I defined how much pressure I want to ask from each of the entries, I advertise my own existence and request in the class sets. So it's essentially read class sets, do something, push class sets. Sleep, read class sets, do something, push class sets. This is all the front end does 24/7. Nothing more complicated than that. So the front end puts in its own class set 4 types of information. Its own identity, the gliding submission regulation instructions, the gliding parameters, and the pilot proxy. If I'm not mistaken, I have this in the next slides. Not yet. I haven't. We'll get those. So the gliding submission regulation, as I mentioned before, it's done on the principle of constant pressure. Actually described this before, so I'll not go again about it. But it is something you have to remember when you try to understand how the protocol works. We don't ask for single glidings explicitly. We ask for a certain pressure to go to. And here is a little bit more in detail how this pressure is calculated. So we match the jobs against a specific entry. We count how many they are. We get a fraction, so about a third, say. And actually I have put here that if a single job matches multiple entries, we actually count that as a fraction when we go here. So if a job matches 10 sites, it's counted as 1/10, not as 1. So this allows for both jobs that match many sites and having multiple factories and still working as it should. Then whatever it counts here, could be a real number, it's divided by 3, as I said, pretty random, but it makes sense. The idea is approximately, we don't want to ask you to keep in the queue as many jobs as I actually need, because there is some delay between I will actually tell you to stop submitting more. So we get a fraction, and a third was a reasonable fraction, so that I have time to react if any glidings start to run, and maybe a different sites too, and reduce this pressure as things go on. We also cap it at a low number and switch. I think by default it's 20. And the reason for this is that you don't really get many more resources at various sites if you ask for lots of glidings. If you go to a site and ask for 10,000 jobs at a time, or you ask for 20, and as soon as one starts, you submit a new one, you are pretty much guaranteed that you will get exactly the same amount of glidings at the end of the day. And sites really hate when somebody submits 10,000 jobs in their queue through to grab. So this both allows us to be nice to the sides and keep a small amount of glidings in the queue, while still obtaining pretty much the same as submitting a large amount of glidings that just sit there for weeks. And if you're curious, the class this is represented as rec idle glidings. The frontend also then advertises the rec max gliding running glidings, which essentially says, yes, I want you to keep a certain number of glidings in the queue at all time, but if you ever reach this, stop. So essentially, if the front end is slow to talk with the factory, or you are with very small amount of glidings, for example, I want you to keep a pressure of 1, but I really need 2 glidings total. Setting this to 1 and this to 2 will make sure that you will never exceed 2 glidings total, even if the front end has taken a nap and it hasn't responded in 15 minutes, while the site is starting a few glidings per second. Right? It's just essentially an emergency. You don't care about it, it's just in the class set, so you know what it means. The front end actually can remove some of the glidings it submitted. So the fact that we asked for a certain pressure doesn't mean we have to actually use all of those. Assume that you can go to 2 sites, and you said, okay, I have 1,000 jobs, so I will set the pressure on both equally, but one site eats through all the jobs before a single gliding is set on the other one. Now I'm left with 10 glidings in the queue on the second side that is very slow, but eventually you may get you something. You have no more jobs in your queue, so it would be a waste to keep them there. You want to get rid of them. So the front end actually can do that. And has several ways, how to say, urgency mechanisms of how to remove them. And these are a little more in details how it does it. You usually don't have to worry about it, but if you debug things and look at the class sets, it's good to know that if you see this set or any of this, you know that the front end is actually scaling back, and if things still seems fishy, contact the factory because the factory is not interpreting it right for whatever reason. The front end is pretty conservative. It will really keep it to no most of the time, and only when it is really, really convinced that it doesn't need anything, like there are no jobs in the queue anymore, it will go to first this, then this, then this, slowly. But eventually it will go to this and just say, get rid of all my glidings in the queues, I don't need them. It's actually a nice way to clean stuff that would get left behind because of spikes or sites broken or whatever. So, the front end can send attributes to glidings, where the glidings are actually on the worker node. And it can do it dynamically as parameters in the class set, and statically as entries in a configuration file. As we said, we actually deliver files to the glidings, so it can be in the configuration file. The attributes are typically static, simply because while the protocol supports it, there is no real way in the configuration to specify a dynamic parameter right now for the front end. But if this is something you are interested in, it would be good to talk with Parag and Bert while they're here, because the protocol actually supports it and could be easily implemented if somebody would be interested in it.
By dynamic, you mean dynamically computed on the front end?
Yes.
Side?
Yeah, while requesting the glidance. You get a little bit into a funny situation if you do it, because the requested glidings may start hours from now, right? So you don't really know when they will start, so it's a little tricky, but if you have a good use case where that would be useful, it's possible. The protocol supports it. It could be just the configuration right now doesn't have a place for that. So if anybody is interested and have an interesting use case, I think we from the glideinWMS team would be interested to hear from you. Also, what you have in mind would influence how we actually implement it. Because right now we have no use cases. Now, I already mentioned that the proxy is delegated to the factory. Here we go a little bit more in detail how it is actually done. So as I said, the private proxy is encrypted in the class that goes to the factory. Now, you want to make sure that what you encrypt and send to the collector can only be read by the factory and not by everybody around the world, because if anybody can decrypt your message, yeah, it is encrypted, but there is no security involved. So, yeah, it's public key cryptography. So the factory actually provides the public key that it's used to encrypt the proxy in the class set. So unless the public key cryptography is broken, only the factory should be able to read it. Even you cannot really decrypt it back. Now, however, consider this. Anybody can publish a class set to the collector, any of the other frontends. Suppose you have 10 frontends from different VOs. What would happen if another frontend published, I'm a factory, I have a public key, and you would encrypt it with the public key. That external guy could decrypt that key and stole your proxy. So you must make sure that what you are talking is really a trusted factory, and not just anybody that can publish information to the collector. In a few slides, I'll tell you exactly how it is, but right now, I want to drive home the idea that, yes, encryption by itself is not enough if you don't trust the public key you are actually encrypting the information with. It will be in a few slides. Let me first tell you how you actually get the proxies. So a frontend must have at least one pilot proxy, but you can have more than one. Many proxies can be used for priority reasons, especially when you're competing with non-pilot submissions. So if you think about CMS, CMS still has uses both pilot and non-pilot submissions. So we have to, the pilot system, which is glidins, must compete with users submitting directly to the site. So if you use a single proxy for all the glidins, this glidin is supporting 100 users, you will eat up your priority at the site really fast, because a single user will get the same priority as your pilot unless you have special arrangement at the site. So in order to compensate, you can tell the front end, look, you have 10 or 100 of pilot DNs, use all of them, or as many as you're currently using users. So you artificially increase your priority by 10 or 100 or whatever, and this way you actually compensate without really screwing up the, without really gaming the system. Because if you're really supporting 100 users, you should be getting 100 times the priority. So by getting 100 pilot proxies, you actually get it. If you don't have to compete with normal users, use one. It works much better actually than having lots of them. But if you have to compete, that's a nice clutch that works reasonably well. And the proxy selection is plugin based. By default, you get all of them. Here. These are the various plugins, and you will see it in the configuration. You usually get this one. Just says all the plugins you have, but you have others that are a little different if you need to. And you can even implement your own, although it's not really documented, but it's quite easy. So here you have the actual class app that goes to the collector, to the factory collector, and this is the factory class app. And here you see the public key, and these are the other attributes that go in, and you can match any of this when you do the matchmaking. And then the front end replies with a similar class set where it says who it is, what it is requesting, any additional attributes, the key, and various monitoring information. This is actually in the manual, so don't worry if you cannot read it. I put it here just for reference. I don't want to go into details. Now, let's go back to the security discussion. So, the first approximation, everything is GSI authenticated, and everything is based on mutual authorization. The front end admin decides which factory nodes to talk. So, if somebody sets up a factory, it's not a big deal because if you don't explicitly say use it, it will not be used. So this is not a problem. But the factory itself does a similar thing. So if you have front end and you want to use a factory without agreeing with them, nothing will work. The initial connection will get refused at the collector level, as you never exist. And everything is based on X509 DNs and this whitelisting. So unless somebody breaks the X509 protocol, it's pretty safe. Just make sure that you do the DN whitelisting correctly, and Condor does actually a lot of stuff with regex, so make sure you don't do that stuff. So we mentioned that just because somebody advertises a public key, you should not just trust it. Because if we have a collector that supports a factory to frontends, any of the three could advertise the class set with a public key. You want to make sure that you only use a class public key coming from the factory. So how do you do that? Now, the collector, since 7.5 something, or it was 7.3 something, anyhow, you don't have to care about what was before, supports a nice feature that after it authenticates somebody that is advertising a class set, it adds an attribute called authenticated identity, which is centrally, the mapping is centrally controlled in the collector, so only the collector admin can change it, so you can trust it. That will tell you who has actually advertised that class set. So by whitelisting only ID of the factory, and then comparing that against whatever it's in the class set, this cannot be overwritten by the user. This is set by, overwritten by the collector itself. You can make sure that it actually came from the factory, and you only pick those class sets that actually come from trusted factories, and nobody can impersonate the factory and steal your proxy through the deception. So this is the information you will need when you configure your front end in order for the security to work. You will need to have a service proxy to talk to the factory collector, which is here. So you have to have a proxy to even start talking to the collector. And there doesn't need to be have anything common with the pilot proxy. It can be the same, but it can be completely different. It serves completely different purposes. If you choose to use the same, fine. There's nothing to prevent it, but it doesn't need to be. I would recommend not to use it, but just for it makes debugging easier. But that's about it. There is no security implication. You will have to have a front-end security name, which will be used by the factory to actually do the proper handshake. And this is one for the whole front-end, which means all groups all together, and you need to tell it to the factory admins. And you can specify different proxy security class. As I said, each on the factory, different proxies from different POs will map different UIDs. However, you can get a step further and actually say, well, actually I'm serving two groups in my PO with a single front end that I really want to make sure don't step on each other's toes. For example, I don't know, standard users and priority users. I want to make sure that nothing goes wrong and their proxies get mixed or whatever. Because the users that actually run on those proxies have different level of trust inside the field, for example. So you can actually use different proxy security classes, and on the factory they will be mapped to different UIDs. So you get an additional level of security if you need it. And this is one per pilot proxy. The default is frontend, and probably most of the VO admins will just keep it at frontend, single one. And this you have to communicate to the factory admins, and they will find the UID, which you don't have to care about. But their name must be agreed with the factory. So this is what you define and send to the factory. And the factory will provide you some information that you need to whitelist in your own configuration so that you actually trust the factory. And this is the collector at the end. So because it's mutual authentication between the client and the collector, the client actually needs to trust the collector before making a handshake. So you need to know what the collector at the end is. Your own mapping at the factory, which is needed for a handshake, security handshake, which I didn't explain in detail. And then you need the factory mapping at the factory, and this is the authenticated identity that we talked about that makes delegating the proxy in an encrypted class actually secure. So this is all things that you need to have set up and agreed on with the factory admins, or nothing will work. Now, that is between the front end and the factory. Now you also have multiple daemons likely running on different nodes within your own VO domain. You have at least a collector, a SCED, and a front end. And when we go to the installation, I will tell you, it's not really a good idea to run them on the same node. You should really spread them on multiple nodes as much as you can. Which means if you are running on different nodes, that you want to have some kind of network security between them. And the way glideinWMS by default works is expect you to use GSI security for everything. You can tweak it in such a way that you would, I'm saying, I'm running on a very trusted LAN that only I have access to, so I don't want to go through all the GSI bullshit. You still need it to talk with the glidins, but internally I don't care, you can. It just doesn't come out of the box. So out of the box, you get essentially GSI authentication, and it works really fine. And it's really no good reason not to do it. Especially if you do something like what we do in CMS, where these three run on different continents. So in that case, you really want to have GSI authentication enabled between the nodes. And this is all I have for this talk.